Moving into the explicit solver section, I'm going to select the routing method, and these are going to be the options. So choosing between dynamic or kinematic, we're doing dynamic. This is going to solve the complete one-dimensional Saint-Venant flow equations and therefore produce the most theoretically accurate results. These equations consist of the continuity and momentum equations for conduits and a volume continuity equation at nodes. The kinematic method solves the continuity equation along with the simplified form of the momentum equation in each conduit. The latter requires that the slope of the water surface be equal to the slope of the conduit. If you're using this form of routing, you cannot account for backwater effects, entrance and exit losses, flow reversal, or pressurized flow. And then next we'll choose the surcharge method. The two options are extran and slot. If you're using extran, this is going to be the original swim method to simulate pipes under pressurized conditions when the nodes at both ends of the pipe have a water stage higher than the top of the pipe at the node. Extran switches the equations for pressurized pipe flows. If you choose slot, this method is used for simulating pressure or surcharge flows for gravity conduits by adapting the conceptualization of pressurized flow to fit a free surface model. If you'd like more information on this, you can visit the EPA swim help documentation online. We'll be choosing the extran surcharge method. Allow ponding at gravity structures. This is going to let you select whether or not you want to allow excess water to collect at gravity structures and to be reintroduced into the system as conditions permit. But in order to actually have that ponding occur at a particular node, you have to enter a non-zero value for the node's ponded area attribute. This next setting is used to identify and treat periods of time when the system hydraulics are not changing and they are considered steady. So I'm going to say false here. We can also apply a swim control set. That's going to be added to the calculation run. If you say true here, then you would additionally need to go in and edit that control set. For the minimum conduit slope, I'm going to set that to the recommended lower limit of 0.001. This option will allow you to turn on stability option to improve the transition from gravity to surcharge flow. And here's some additional information on the Bentley transition equation. For the swim pattern mode, I'm going to leave to use swim patterns. And next I'll look at solver compatibility. So we have two options here. You can either use EPA or Bentley. I'm going to go with the Bentley Enhance. And here on the left side of my screen are a list of those enhancements. If the compatibility mode is set to EPA, the Bentley enhancements are going to be turned off, and that would be done in order to match the EPA swim capabilities. Next, I'm going to set the tractive stress that's required to have self-cleaning conduits. So I'm going to just enter in a typical value for that, 0.018 pounds per square foot. Moving into inlet transition depth, this is used when figuring out when to transition between HEC 22 inlet calcs and full dynamic calcs. When the inlet is surcharged, the Saint-Venant equations based dynamic calculation is applied instead of the HEC 22 based calculation. In order to achieve smooth transition and switching between such equations, the model needs a small transition depth within which the equations are gradually switched. The smaller this transition depth is, the more accurate your results are going to be, but the model will be less stable. Typically, values are within 0.1 to 0.5 feet, and the default value for this is going to be 0.5 feet, which has proved to be satisfactory for most conditions. Next option is to choose if you want to split downstream surface flow between gutters, true or false. This is only going to apply to gutters that use the gutter sections that come from the terrain model and that also are discharging to the same inlet or outfall. So if we have this set to true, the surface flow to the downstream structure will be allocated to the gutters proportionally by gutter length. If you're in the United Kingdom and you want to specify the grading parameters for the different grade types, then you would do so here. Next, you want to set the pressure friction method, as well as any frequency factors if you use those.